Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to illustrate an example that combines what you have seen about the effects of the first derivative and the second derivative on graphs. So for this particular example, we are going to look at this curve and we are going to discuss it with respect to concavity, points of inflection, and local maxima and minima. Okay, so first of all, we have this function here, fx, which is equal to x to the power of 4 minus 4x cubed. And then I'm going to differentiate this function, find the first derivative, and the answer is just 4x cubed minus 4, 3x squared. And this is just equals to 4x cubed minus 12x squared. Now, of course, like I have said, or like I have mentioned earlier, it is better to construct the expression in terms of factors. And that can be written as factor out 4x squared. So we factor out 4x squared and we'll be left with x. And here you will have the value of 3. Okay. Now, in order to find the critical points, we have to set f prime x equals to 0. So this is to find the critical points. Therefore, 4x squared x minus 3 will be equal to 0. And here we have two scenarios to consider. The first one is 4x squared equals to 0 or x minus 3 equals to 0. So by considering this, we can see that x squared must be equal to 0 and therefore x must be equal to 0. For this one, x must be equal to 3. Now, these 2 points that we have here are what we call the critical points. So, these are the critical points. Now, based on these critical points, we are now going to divide the horizontal axis into proper intervals. Okay, so I'm going to construct a table now. So, the table contains the interval that is based on these 2 points here. So the first interval is for x being less than 0. The second interval is for x between 0 and 3. And finally, the last one is for x greater than 3. Next, we are going to study the behavior of f prime x, and that's why we need to consider these 2 factors separately. So the first one is 4x squared, the second one is x minus 3, and based on the combination of these 2 factors, we should be able to determine the behavior of f prime x. And based on that, we'll be able to see how our fx behaves. Okay, so now for x less than 0, that means x has a negative value. You can see that clearly if you plug in a negative value here, the result is always going to be positive because we have x squared. So this is going to be positive. But for this one, if x is negative, the whole expression that we have here is going to be negative. Therefore, you multiply the 2 factors here, the sign will always be negative. And based on that, we can say that fx is decreasing on the interval negative infinity to 0. Okay, the next one is x is between 0 and 3. You can imagine any value such as maybe x equals to 1. So if x is is equal to 1, this is going to be positive, this is going to be negative, and the result here is going to be negative. Positive times negative is going to be negative. So again, the graph is decreasing on this interval between 0 and 3. Now for x greater than 3, for example, x is 5, let's say, so this is going to be positive, this is going to be positive, and therefore positive times positive is going to be positive. Therefore fx is increasing on 3 until infinity. Okay, now based on this, this is the first derivative test. Now based on this, we can actually determine the local maxima and local minima. Remember that local maxima or local minima means there is a change in the direction. So we're going to see that based on the answers that we have in these two columns here. So for the first one is for x equals to 0. So for x equals to 0, I can visualize 0 at this point. So now we're going to see the behavior of x less than 0. For x less than 0, it says here that the graph is decreasing. So you can imagine the graph decreasing maybe like this, in this manner. Now how about for x greater than 0? Just immediately after 0, the graph is also decreasing. That means it's just going down some more. So it doesn't change direction, it's just going downwards. And because of that, according to the first derivative test, okay, so according to the first derivative test, this one, if f prime x doesn't change sign, then function fx has no local maximum or minimum at c. So that's the conclusion that we can say for that. Okay, so because it doesn't change sign, it is decreasing, and again it's decreasing, the sign doesn't change. So the conclusion is, at this point there is no local maximum or minimum. Okay, so now let's look at the next point, which is point 3 here. Okay, so I can visualize having point 3 somewhere here. So for x less than 3, the graph is decreasing. So you can imagine the graph is going like this, decreasing in nature. But after x greater than 3, for x greater than 3, the graph is increasing. So you can imagine that the graph is going upwards in this direction. So you can see that the direction is changed from this direction, and it is changed upwards. And clearly you can see that this point here must have been a local minimum. So again, if you look at the first derivative test, again we are going to refer to the first derivative test. If f prime x changes from negative to positive at c, then this function has a local minimum at c. Okay, so let's see what we have on the table. So it changes from negative to positive. That means the point here is a local minimum. So that's the conclusion. This is the local minimum point. Okay, so there you go. We have done or we have determined the local maxima and minimum points. In this case, there is no local maximum, there's only local minimum. So there is also an alternative method to determine the local maximum or local minimum. So this method uses the second derivative test. Okay, so what we need to do is first, according to the second derivative test as given here, if f prime c is equal to 0 and the second derivative for c is greater than 0, therefore the function has a local minimum at c. And if the second derivative is less than 0, the function has a local maximum at c. So we are going to just apply the alternative method. So now C is this one. This is the critical point. Okay, represented by C. So when C is 0, clearly that you can see if you plug in 0 into f prime x. Okay, so if you plug in 0 into the first derivative here, you will get that the answer is going to be 0. Okay, so that's the first part. This is 0. Clearly the answer is 0. Next, the second part is I need to plug in this value into the second derivative. So my next step is to differentiate this function once again. So I'm going to differentiate this function. This is easier to do compared to this one. So what I'm going to do is I'm going to get the second derivative of x, and this is equal to 3x squared minus 12 2x, and this is equals to 12x squared minus 24x. So you can write it in terms of factor. So this will be 12x, so this will be x minus 2. So if I plug in 0 into this second derivative, so now I'm going to plug in 0 into this second derivative. So f double prime 0 is going to be 12 times 0 is 0, so everything will become 0, and because of that there is no conclusion. Because according to the second derivative test, it is either greater than 0 in order to be the local minimum, or less than 0 in order to be the local maximum. And in this case, since the answer is 0, that means there is no conclusion, which is similar to the one that we have obtained here. There is no local maximum or minimum at this point. So now let us check for x equals to 3. So what happens when c is equal to 3? The critical point is 3. Obviously, when the critical point is 3, f prime 3 is going to be 0. So you can plug in 3 into here. So 3 minus 3 is 0, so the whole thing becomes 0. Next, what happens when you plug in 3 into the second derivative? So if you plug in 3 into the second derivative, 3 times 12 is 36. 3 minus 2 is 1, so the answer is going to be 36. 36 is a positive number which is greater than 0. And according to the second derivative test, this one, okay, we got the answer is 36. 36 is greater than 0, and therefore we have a local minimum at that point. Okay, so according to the second derivative test, c equals to 3 is the local minimum. Okay. Alright, I'm just going to stop here, and I will continue the discussion with respect to concavity and points of inflection in the next video. Thank you very much for watching.